Okay, so the no more regrets term comes from a feature that we call the regret feature. It was coined by Michael Demer when they came in, because the way Slack is originally sharded is not the way it's sharded in Vitess. And what Michael wanted was the ability to reshard like Vitess does, but to reshard using a different key. And the reason why he named it as Vitess is because you start off with a sharding scheme and then you realize, oh, this was a big mistake. And then you say, oh, I regret doing this. And that's why it was named the regret feature. So it's been in the back of my mind for quite a while. And as other feature requests started coming in, everything kind of came together into this VReplication feature that I'm going to talk about. So, not many people got the Rachel reference here, but if you haven't gotten it, ask somebody else who did. Okay, so what is VReplication? So VReplication is the ability for you to materialize anything from anything to anything, anyway, anywhere. Is the easiest way to put it.
Also cures gout.
Also what?
Cures gout.
Cures gout? I was going to say make a sandwich. Yes. I don't know if you can make a sandwich yet, but you can do a lot of things. So to best talk about what VReplication is, we are going to go through a journey. Let's say we are building a company, and we are building a marketplace. And in this marketplace, customers come in and they order products from various merchants. Very simple story, right? So customer, there are products, there are merchants that sell those products, customers come in and just buy them. And this is how kind of the schema that you would represent. And it looks simple, but if you look at the orders table, it has some problems. The reason is because orders has foreign keys into all these tables. So everything is fine if everything is in one database. But as soon as you decide to split it up, product goes into its own database, customer in their own database, merchant is in their own database, they are all sharded by their own keys. What do you do with orders? Where do you put it? And so far, the answer has been, you have to choose. You say, find out what's your highest QPS, find out your transactions, and say, orders, better to be with customer. That's the decision we make based on my query pattern. But that may or may not be true. That may or may not apply to all your use cases. But if you decide to shard a system, this is a trade-off that everybody has had to make. And VReplication obviously is going to solve this problem. And I'm going to give you a demo about how to do it. So this is kind of what the schema looks like. In this case, the product is an unsharded database because it's a small table. Customer is a sharded database, and the orders for a customer live with the customer. Merchant is its own sharded database, and they are all three different things. Okay, and I should have done this, which is bring up my cluster. While the cluster comes up, so this is a 5 master cluster that I'm bringing up, which is 1 lookup database, 2 customer databases, and 2 product databases. I only have 5 masters, so this is a full Vitess cluster running in my laptop. And there is a vSchema in there. The product is unsharded, so no sharding key. The customer's sharding key is the customer ID. The order's sharding key is also the customer ID, which actually makes sure that the orders live with the customers. And the merchant's sharding key, for fun, is a Unicode Vindex, just to show that we can. All right, let's see if my app is up. App's up and running. I'm going to see if this works. Okay, so this is my topology. Let's see if the topology is up. Topology is up. 2 shards merchants, 2 shards customers, and 1 shard product. Let's see, ooh, spoiler alert. Okay. Don't look at those red things. They don't exist yet. Okay, here we go. So this is exactly the schema that we saw in the beginning. Product, 1 shard, 2 customer shards, and 2 merchant shards. I'm going to populate it with some data. Since you all know how sharding works, I'm going to say, I have this data.sql. You will recognize some names in here. Okay, so I have 2 customers, Sugu and Temer. The names were chosen only because they fell in different shards. There is, Sugu has ordered something from Monoprice, something from Newegg. Temer has ordered something from Monoprice. Just a very simple populated data. And in this case, in Vitess, even though these are different databases and key spaces, you can treat it as if it is one unified database. You can say select star from product. And so the way this application works is it shows you everything, all the tables. You can type in any query you want, and it tells you the result on the left, and it also tells you what it did with your query. So in this case, it said, I sent this query to the product key space. You can say select star from customer. I'm not qualifying it. I'm just saying select star from customer. It says, oh, I went to the 2 shards that customer has, fetched all the rows, and returned them. You could obviously qualify the customer by the key space. That will also work. And there you go, it did the query again. Now, here is a join. So this is a join saying that give me all the orders joined with their customer. What should Vitess do in this case? Because customers' orders are living with their customers, it should do a simple scan. It says, send the entire join to each of the shards, and the results as they come, I can put them together and return them. So far so good. Now here's a more complicated query. So this is a query that says, select the customer's name, select the product description, join with the order. So go from the customer, go to the order table, and then jump to the product and get the description from the product. So this is a cross-shard join. Let's see what Vitess does with this. It has to do a lot of work. So it says, send a scatter, get all the customer information. And then for each customer information, go to the product table and fetch the product, fetch the description by product ID. So that is basically what it did. It's kind of a pain, right? What if, I mean, the product is a small table. What if you could materialize that product table into each shard of the customer? In that case, everything would be a local join. But the problem is, if you did that, you have to keep that product table up to date. If you insert something into the product, you have to go and make sure to do all that. This is one problem that VReplication solves for you. And the documentation for VReplication is here. You can go to vitess.io. There is a lot of documentation. So the feature I'm showing is actually a complete refactor of the old resharding scheme. So what we have done is actually componentized all these parts and made it completely composable. So the VReplication feature is slightly complex. You can see that the commands are kind of heavyweight, but they allow you to build some super powerful things, and the demo is about all the things we can show. If you're a geek, you can go in and make it happen, but if you're not a geek, somebody could actually build a script for you that puts these things together into whatever you like. And I'll show you an example of one thing that I did with this VReplication. So in this case, the way you have to do it is, you have to go to Vitess and say, first, create tables. Create the product table on all the shards. And then you say, replicate from the source to the target. And then do some routing magic saying what should go where. So all of this, I'm going to show you how I did it. There is a simple command that I built, which is here. And I'll explain, is this readable? make it a slightly bigger. Is this better? Okay. So I have cooked up this materialize command. This materialize command takes the workflow as input and says, I need you to create this table for me. This table is a reference table. The meaning of a reference table means that it is not sharded, which means that there's a full copy of the table on every shard. And I want to materialize product.product into customer.product. I just hit that command. Now let's see, you saw some of those reds in there. Those reds will disappear. You can now see product is now materialized into every shard. So VReplication did a few things. What it did was it actually copied the source table into the target and has set up continuous replication. So there's a lot of work that goes behind it. So this works even if your table was like 5 terabytes. And while it is changing and serving traffic, VReplication can still do a consistent copy of the source table into the target and set up replication. So that's one thing it can do. And here, let's see, but there is a problem here. If I run this query again, for example, it's going to fail. Why is it going to fail is because now there are 2 product tables. There is one product table in the source, and there's one product table in customer. So you have to now tell Vitess what to do when I talk about product. So this is where we introduced a feature called routing feature. So you can tell VTGate how to route a query that comes to a table. And the cool part of that routing feature is, I'll show you the command, and I'll apply it too. So it says, I'm going to, please apply the following routing rules. If there is a query that addresses the product table, you have 2 options. You can either send it to the product in product or the product in customer. And feel free to choose whatever works best for you. So now, if I did select star from product, I'll go to product and select it. But if I ran the other query, which is select the big join that did all this crazy back and forth, now if I run it, it says, oh, there is a product locally present within customer itself. I will use that. Now it becomes a very simple scatter query, totally efficient. All right, next feature. Now let's look at merchant. Here's a query. Merchant wants to know all their orders. Select all the merchants, and for each merchant, find out all the orders that the merchant has. This is a query of even higher complexity because you do a scatter query on the merchants, and for each merchant that you receive, you have to do a scatter query on the orders because any of the on the customers, because any of the customers' shards could have the merchant's orders. So this is a very, very bad query. And you have to live with this. If you made the choice of putting orders with customers, you have to live with this choice. What if you could materialize the orders into merchants, but then order is sharded by customer ID? But is there a way to materialize this by merchant name on the target? And that is another thing that VReplication can do for you. I'm going to run that command, which is this one. So this one says materialize. Again, I've given it a workflow name. Remember merchant order as a workflow name. It will become handy in the future. I say I want you to create a table. This time I'm saying the target table as a primary index. The target table's primary index is the column merchant name, and it uses the Unicode lose MD5 sharding key. So by this, what I'm saying is that I'm going to materialize the source table to the target, but the target is sharded differently. And then the source and destination. Let's see what it did. Well, Ronak built a cool UI, but I panicked. I didn't want to try it out, so you have to live with the old UI. as you go. Now you see merchant table has its own order, and you can see that they are, the rows are sharded differently. All the monoprice rows are with the monoprice merchant, and the other rows, the new egg rows are with the new egg merchant, whereas in the source, it is different. Of course, this is not a perfect demo. If you look at the V schema, it's kind of awkward. I'll have to fix it. Because KVSTL get V schema, was it merchant? KVTCTL, all right. Okay, so you can see that the merchant's index is MD5, and the orders index is Unicode loose MD5. They are named differently, even though they are the same. So this is because I did it in a hurry. There is a way to fix it. So I'm going to do a quick fix of the V schema. I fixed it. I said, oh, please change the V schema for the orders to use the same as what the merchant is using. And the next thing I'm going to do is even more crazy, which is, again, now we have two tables. We have order table both in customer as well as an order table in merchant. So I have to tell Vitess again how to route these queries. You don't have to tell Vitess, because you could, for example, go here and say, if you, let's say, go back to this query, you could say join customer, join merchant dot orders. And then it did a local join. But then for a better user experience, you want to treat the entire orders table as one table and Vitess to route queries to different charts. The way you do that is by applying again the same routing rule that I showed you that I did for which table was it? For the product table. I'm now going to apply it to the merchant table. And now I can now run this query without qualifying, and it will choose the best plan for you. All right, so far so good. Okay, the last one. So, how nice, great, the boss comes and says, I need you to keep summarizing our sales figures. I want up-to-date sales figures. I want this all the time. And every time you ask for sales figures, you have to go in and then do a full table scan of this order table. And it has billions of rows. What if we could summarize those into a table, right? So typically this is done into data lakes that you export, but you can do this within Vitess itself using VReplication. How do you do that? Is I'm going to show you the next feature, which is the materialization ability of Vitess applies to, so I'm going to now create a materialized table, which is just creating the schema. And then I'm going to say, please create a view. So this view says, in the previous cases I said materialize the table, which means all the rows of the table. In this case, what I'm saying is materialize the new table, but don't materialize all the rows as is. Use this select expression. So what Vitess will do is we'll create a table, populate it using this select expression, and then keep it up to date. Every time, as soon as you insert a row, it'll actually update this target table with the final results of what the query would look like. So let's see whether it did that. 3. And there's your sales table. If I went and inserted something, let's see, insert something here, then it updated your sales figures on the fly. And this is very efficient and very fast because it's just an incremental update to the final table using win logs. So, which is super cool. Now, I talked about the regret feature. What does the regret feature have to do with this? So if you go and look at, we are going to change the story up. I didn't have time to build a brand new story, so I'm going to build on top of this. So let's assume that we regret having sharded orders by their customer. Our use case really requires orders to be sharded by merchant. Now you can see that we have pretty much done more than halfway in terms of changing our minds. All we have to do is, at this point, instead of sending writes to orders in user, say, flip it around, send your writes to merchant. And you can tell Vitess to do that. And the way you do that is, you remember when we went and created this materialized view, we gave it a name. Using that name, you can perform workflows. So here is a workflow. I'm going to say VTCTL migrate reads. All RD-only traffic now goes to merchant. Now migrate reads to replica. All replica traffic. This is a standard. Some of you are smiling, those who have done resharding. You are required to do this in Vitess because you are required to test your reads before you migrate your writes. And then finally, you migrate the writes. So before you migrate the writes, since I'm running out of time, I will not surprise you too much. I'm going to show you something. VTCTL, I'm going to type some VReplication exec. Okay. So how does VReplication work? Is basically you insert control records into the metadata table of Vitess, and that record actually dictates your VReplication rules. So this is basically what a control record looks like in Vitess. And these are the VReplication rules for the sales figure. So sales says that product sales is sourced from customer and has one source from shard 80, the other one is from customer to 80 dash. It performs the select that I gave. So all this metadata is there, and this is what is driving VReplication. So now I'm going to migrate writes. Oops, what did I do? Copy plus. So I'm going to do the final migrate writes. You know where I'm going. There is a problem brewing here. So I'm going to now migrate writes. I've migrated writes. Now I'm writing to orders in merchant. I'm not writing to orders in user anymore. Actually, now if you refresh this, it's going to show up pretty messy. Because one thing that Vitess does is, as soon as you migrate writes, it blacklists your source table, saying that you can't write to that anymore. It's a protection mechanism, because once you migrate writes, you don't want to accidentally allow writes to go to the source. So now the writes are going to the target. That's one problem. The other problem is what happens to sales table. It was replicating from the customer database. Now you have to go and fix it up. You don't know where it stopped. You don't know what happened. Worry not. It takes all of that for you. I'm going to retype the same thing. Look at what it did. It actually deleted the old records, created new records, and switched to merchant for replication. Yeah! Yes. So, so there are a huge number of things you can do with this. Like the cutover that I talked to you about, what it can now allow you to do is you can do one-to-many resharding. These are things you could not do before. You could say, I want to take this table from this unsharded table and deploy it into this sharded key space. Or you can say, take this table from a sharded key space, put it in an unsharded table. Or the other flip-flop one, where you say, I want to completely reshard this table into it using a different key. If you're doing shard splitting, you could either do only split or merge. Now you can say, I want to do a split merge, where some shards go this way, some shards go that way. So all that is now possible. And if you have set up VReplications from those tables, you don't have to worry about going back and fixing them and adjusting them. VReplication will automatically jump over and follow wherever you reshard your data. So that's the complete story of this whole VReplication. And it's been about a year. I think a year ago I showed a demo that looked exactly like this, but now it is real, it's production ready, you can all start using it. So that's the only difference between last year and now. All right. Any questions? Okay. Yes.
So when you migrate serving types, how does the work you have 5 replication streams? You need to stop the war, what they will catch up. Like how does that scale? Is it safe to have like 10 replication streams and then you regret and you have to fix all of those other streams?
Are you talking about the resharding stop the work or the VReplications that depend on it?
The replication that depend on it. The
So-
step that you showed, you know, like you fix it automatically.
Correct, yeah. So if you look at the steps of how Vitess does the failover, he stops the traffic on the source, no writes go, and then wait for the destination to catch up. So until then, no writes are going to the source. After the destination is caught up, it goes and collects the binlog positions for all of them and writes actually a resharding journal entry into the source. And then it opens up the target for writes. So anything that is subscribed to this source up to that point has only seen events pre-resharding. The next event they will see would be this resharding journal event. And what does this resharding journal event tell you? Stop here, your new destination is your target destination, replicate. So it tells you for each shard what is the position, and these replication streams then drop what they have now, switch to the new positions and new sources, and then they continue. It's complex logic because it needs to work even if you are crisscross sharding, that could be overlaps, not overlaps. So the replication streams actually talk to each other and they have to wait. Like for example, let's say you're doing a merge, and then I'm re-replicating from both shards of the source, and suddenly you merged into one. And one of my sources would say, oh, I see a journal. I'm not allowed to immediately jump in and continue from there because I have to wait for my neighbor to also catch up and finish. And they both have to converge on the point of the journal, and then they split and then go to the new destinations. I don't know if that makes sense. So all that consistency check is needed, and all that has been written. Right now, the only thing is there are a few corner cases where it could move forward. It is a lot more conservative now. Now it says you should do the resharding from 5 to 10. It waits for all 5 to happen before it does the cutover. There could have been 3 went to 5 and 2 went to the other 5. If I saw these 3, I could continue. So that kind of optimization is not done yet. I don't even know if it is worth it. So I think this, for now, feels like a very good start. And if there are corner cases, we can address them as we go along. Yes?
Why do you need the routing rules separate from defining the view?
So the routing rules are needed. Was actually a feature request from someone. So initially, in the original demo, I actually gave different names to those tables. You could say, I want to join with the order in user, I want to join the order in product, and that would have worked fine. But someone was not happy. They said, no, my application already is hard-coded to use product, and I wanted to transparently start using the new product if it ever needed to. And so I said, well, when we built the routing rules, it kind of said, well, if you're going to build this, might as well make it do more stuff. So the routing rules are not only used for this type of routing, they now also handle the routing during resharding, going to redirecting traffic to replicas, and RD-onlys are also taken over by the routing rules. So it's it's very easy to read it, it's very easy to modify it. So the cool part of the routing rules.
So just to build on Ilya's question,
Yeah.
is there any particular reason why the materialize command and the routing rule command have to be different?
Oh, I did that only because I wanted to expose the routing, explain the routing rules as a separate thing. I could have made it part of the materialize itself.
All the information is already.
It is there. I wanted to just keep it as, so that I could explain, because that's a cool feature of Vitess, and you can use that independently of everything else. So each of these pieces are different things, you combine them differently. I just combine them one particular way.
Maybe a leading comment to that as well. Would you say that the routing is related to the consistency model as well, or not? Because the VReplication kind of copies are eventually consistent.
Correct.
You should kind of opt
Correct.
in.
You may not want the routing rules. You may want explicit routing, because when you read from target, it is lagging behind the source. If you want up-to-date data, you may want to specifically read from the source. So that's a good point. Yes?
Is there someone running these on production at the moment? Has there been any?
Yes, there are some people that have accidentally started. No, not. So I guess I can talk about this. Many of you know Derek from Nozzle. He's well known in the Vitess community. So he did a big mistake. He added auto increments. The auto increment sequence thing that he did ended up creating duplicate IDs across shards. And when he was trying to do a merge, these things collided and said, oh, you can't do it. So he talked to me and said, hey, is there something you can do to help? I said, oh, of course. What else? VReplication. So he did. Now anybody comes ask me anything, the answer is always VReplication. So I made him build a new materialized view that did a select ID, count star from all shards into a target. And boom, we just told him all the duplicate IDs, and then we can just go and fix them. I hope he's okay with me talking about him. I didn't get his permission, but so so it tested the copy, it tested the consistency and performance. He found some bugs and has reported them, all minor bugs so far. Yeah, so it's in use, and there are other people. There is another company, I don't know if I'm allowed to name them. They have done, they've been waiting for this feature because they're a customer, they haven't revealed themselves as Vitess users yet. And they've actually performed full vertical resharding using this. We are in Asia somewhere, is all I can say. Yes?
So, VReplication puts increased write load on those destinations. Do you have throttling in there?
That's a very good question. And as a matter of fact, that was one of our files complaints, it's going too fast. So the one, when we did the VReplication, I fixed a large number of performance issues. Now it is actually screaming fast. And it tried so fast that the replicas are struggling to keep up. And my intention is to see if we can integrate with Freno, because people are saying great things about it. Freno is actually a tool written by Shlomi that allows you to throttle writes to a master database, and you can customize rules about how to throttle it. And the most popular use case is it watches your replica lag and tells you, hey, slow down, replicas are falling behind. So that's what I've been thinking about.
So do I understand correctly, it matches them? So it falls further behind, it should catch up a little bit, or reduce its pain in it?
Right. So the way VReplication works is the farther behind it is, the more it patches your transactions. So that's the cheating we are allowed to do that MySQL is not allowed to. Which means that if you are far behind, we can just patch multiple transactions together as one. So that's like reduced number of IOPS. So that is what allows VReplication to go really, really fast.